So hi, it's Haischel Dabian. All right. All right. So first, before I start, I'd like to introduce our company, our startup, and what we do, and then go into what we did at the hackathon. So our company is Kryha.io, and what we do is we help organizations better understand and basically adopt blockchain technology. So we help them from the ideation phase, we validate use cases, we have a platform agnostic view, so we choose the right platform for a given use case, and then we actually build prototypes in-house. So this is half of our team. This is mostly the developers. This picture was taken at the hackathon. So as you can see, we look quite bad. We didn't have much sleep that weekend, but totally worth it because we won. So I'll start at the hackathon. This is basically a timeline to keep track of what's been going on since the hackathon. So the hackathon was a Blockchangers hackathon, and we participated in the machine-to-machine economy track. And what this means is it's the track, the crazy shit track, as Jan Peter always says. And it's about envisioning the world of tomorrow. So the future world where us humans are liberated from performing tedious, hard, and especially dangerous tasks. A world where we have autonomous machines basically collaborating and figuring out stuff by themselves and doing all of these work so we can lay back and enjoy our lives and do whatever we want. So this was a tough challenge. We had a lot of debates with Jan Peter. He basically was pushing us to break through the thoughts of today and basically think about the world of tomorrow. So what did we come up with? So we came up with Grex, World State Consensus. So this is we built a small piece of the whole concept or the whole idea, just to prove basically that this small piece is possible. And what is it? So it's autonomous agents. So think about drones, autonomous vehicles, or whatever autonomous machine that basically agree on a world state. So they all roam around, they sense, they gather data, and then they agree on what they see. So they agree that maybe it's raining in some continent, or it's whatever they agree on. Yeah, so they agree on that. Next, once they agree on a certain state of the world, they are able to collaboratively perform actions. And it's all built on distributed ladder technology. For the hackathon, we specifically built on top of BigchainDB 2.0. And it was quite a hassle back then because it was still in the alpha phase. We had to collaborate really with a lot with the BigchainDB team to basically pull it off. So once you have all of these autonomous machines, we specifically chose drones for the hackathon. They can start doing all kinds of stuff. So think about planetary observations, even building buildings. So they deliver resources, they stack them up, put them all together. Search and rescue. So think about like a new species of drones that are flying around, roaming, constantly looking for people that are in trouble and trigger some action so that other drones can come help them or save them if they're in desperate need. Or wildlife protection. So some drones hunting poachers, basically, the hunters being hunted. But yeah, so once you have these machines collaborating with one another, you can do all kinds of crazy, cool shit. Sorry for cursing again. So what did we do at the hackathon? We actually brought a few hardware. We brought rolling drones, we brought air parrots. We weren't allowed to fly them by Rutger. But we used the small ones. Exactly. And what we did was we retrofitted these drones with Raspberry Pis. And on top of that, we ran a whole BigchainDB node. So each drone has its own node. They share information with one another. Whenever one drone sends an update to the ledger, everyone or every other drone automatically knows what's going on. And what we built was we built a grid. So every drone has the same view of a grid. And they're just flying around. We simulated search and rescue specifically. So they're flying around. They identify a point of interest. So someone in trouble, for example, and they send a transaction to the ledger. So now every other machine that's participating in this network knows that there's someone in trouble at a specific point. So they send, once it's updated to the ledger, another drone that is able to carry this person can go to that spot, pick up that person, and save him. So that's just one small piece that we built at the hackathon, but we're here for Nature 2.0. And the whole concept was you have drones, but in order for these drones to fly, they need energy, right? So you have other species of machines that also participate in this network. You have solar energy, basically plants. So these drones can just come, fly themselves in, and then be on their way, always continue moving, doing their mission. And then you have 3D printing factories. So whenever a drone is damaged, they go there, if they can still fly. They get repaired by the 3D printer, or if they're totally dead, some other drone can pick them up, deliver them, get them repaired, or just you print new drones if you need new drones to be added to the network. And lastly, we had beacons as well. So beacons we placed in areas that are more popular. So if there's an area where people always go, instead of having drones flying around, you can just put a beacon there and it's always checking if someone is in trouble. And once you connect all of these machines together, you have a whole ecosystem of machines that are self-sustaining, and they can always keep on operating. So the drone delivers resources to the solar energy plant. And so they live in symbiosis, or I think I pronounced it right. Same for the 3D printing factory. It needs resources. The same drones that get built there are the ones that bring resources to the 3D printing factories. So yeah, that's how you close the whole ecosystem, and it's fully self-sustaining. All right, so since the hackathon, we've been busy basically validating the concept. So we have the initial proof of concept set. And we've been busy talking to all kinds of, basically everyone that we know or we find interesting to participate and contribute. So the green tags are areas we've been and physically visited and met with people. And the yellow ones are people we're contacting. Especially the one in Massachusetts is the guy that basically inspired the idea. His name is Eduardo Castillo, yeah. And he's been researching this topic for some time now. And yeah, we're trying to figure out how we can collaborate and basically bring this closer to reality. So now Dan will take over. Dan is responsible for R&D.
Yeah. Thank you very much. I really like how we're talking today about visions and about how this could be, about the future ecosystems. It's nice, but this is one moment when I really didn't click with Jan-Peter in the beginning, because I really think I have a business background. I've been a hacker for a very long time, but I also have a business background. So I have to put everything in the world of today. I have to understand how can we make this go forward. Lower? Okay, fine. Higher, okay. So after this, we've been talking, we've been trying to understand what did we build? I'm trying, sorry. What did we build? What's the point of this? How are we moving forward? So we started doing these things. It's called the pillars of Grex. It's a very weird idea, but just stick with it. So we built a world state consensus. That's great if you have drones with data. Oh my God. I think you can still hear me though. Okay, true. So that's great of an idea, but you need data for that. You need some way to manage which drone participates in your network. You need to afterwards be able to make sure that these drones are autonomous so that they can learn, they can pick the missions that they want Afterwards, it's really complicated, it's really annoying, and when you're head of R&D and you're just thinking about this for the entire week, you start really going insane. So we split it up. These are the pillars. The Grex network is just a distributed data network. It's really IPFS style, academia based. We're still developing its concept stage with a couple of POCs that we've built, but that's it. You need a decentralized data storage network in order to enable this. Then what you want is we're calling it market. By the way, these are all domain names that we own. I love buying domain names. Stick with it. So market is just the decentralized user access control that we have. In order to have people access this data, or the drones to have access to it, you need to make sure that there's some way of controlling who has access to it. So you don't want to have a central server. You don't really want to have some third-party authority governing this. But what you really want to have is this decentralized user access control. Right now, we thought about Tendermint. We implemented with Tendermint, but we're still thinking about it. And on top of that, you need to have somebody who grants this control on this network. So something that is on a permissionless network that can govern something that is permissioned. First idea that came to mind was a DAO. So technically doable. We're not at the stage where we're implementing that because we still need a use case and a client for doing this specific part. Then you have the world. This is the world state consensus. It's been a bit explained, just everybody agreeing on parsed data. So just make sure that first you have the unparsed data, and then once everybody understands what data is, what's the current state of the world, that's when you have parsed data. And then the beautiful part is decentralized federated learning using blockchain, which I'm going to talk about a bit later. So why is this so important to Nature 2.0? So we really tried to come up with one way of explaining it. It's called a decentralized infrastructure for autonomous agents and multi-agent systems. Why is this interesting? Because in our words, Nature 2.0 is a self-governing multi-agent system composed by autonomous agents. See the link? The self-governing part, that's where we think is the AI DAO. We don't have yet the skills nor the technology to do that. So we're going to work on that later. After that, we were so in order to have a decentralized system of a world state consensus, you need data. If you have drones for data, bad idea. Regulations are horrible. And having drones flying all over the world, people get terrified. We scratched that and we went, okay, what happens if we combine 3 pillars? So we took 3 of them and we're like, oh, wait, what about satellite constellations? So currently there's a lot of companies working on satellite constellations. You have OneWeb, SpaceX, those 2 are focused on internet. There's Planet, has a beautiful idea of scanning the world once every day, everything. So you have this data now. Okay, but the frequency is only 1 time a day. How do you incentivize people to have higher frequency of data updates? You incentivize them to collaborate on a constellation, because if you want to have total global Earth coverage really fast, you need at least 50 really amazing satellites, but probably more. So we thought that if you have a decentralized network in space where everybody can contribute based on their own satellite, and they own their own satellite, but the data is public because everybody can just share the amount of data there, okay, that's better. But now you also need the decentralized ground station. So the ground station network where you can distribute the load of the network, because only having 1 single point of retrieving data is horrible because you really have data costs a lot in space. And we're also not storing anything in space because it's expensive and it's useless if nobody can access it. This is where token economics really, it's not even token economics, it's a very stupid token engineering. I have to be honest here. You cannot buy into the system. You can only get access to the system if you contribute. Either a security audit, a launch of a satellite, or let's honestly say maintenance of a ground network. But also, if you have, what? If you have your own ground station, you probably have servers. You probably have access to very decent storage. What happens if we open a relay? Now you actually can sell this access, because I'm pretty sure nobody that produces parts for satellites is interested in storing data about space. I mean, it's worthless to some of them. So you sell it on a secondary market. Now you generate a revenue form for them. So now you can distribute the load of a network with a ground station network. Seems to make sense. We're validating this idea. There's a very nice company called IC Space in Delft. They do most of the launches that were in Europe here. We're validating it. It seems to make sense. We're writing the specifications right now for it, but okay, let's go. Then we are like, okay, this is a very far-pitched idea. It's not going to happen now. It's going to happen in a while. What can we do now? Because if you tell this to a client, because we're an enterprise solution company, they're going to be like, yeah, that's great. No. So we are going to go the academic route for now. We thought that it makes most sense, since this is everybody who works at the company basically has an AI research background, except for me, I'm the weird one. But we really love academia, and we think that such an approach, as this is how it all started, we should continue and we should contribute back. So as Haischel mentioned, we're in talks with MIT Media Labs to submit a paper there for review, because we've got, it seems to be in line with them regarding this. So yeah, it looks weird. It's not a white paper for an ICO. Don't worry, don't get scared. It's okay, it's not a scam. So we're just gonna build this. But fortunately, we talked to Dimi today again, and we found out there's actually a small part of this that we can build now. And since we built the word state consensus at the hackathon, it's just a concept that we built and we proved that it works. We're gonna document that academically, submit it. But then we realized that doing distributed federated learning on blockchain is not that hard from our perspective of our knowledge. So today we're like, oh, we're gonna build this now. So fortunately, in the next paper, because this is just a description of what the concept is and what technology we used. Perfect, thank you. How you can do distributed federated learning on BigchainDB. So fortunately, you're gonna see an update from us in the near 3 to 4 months, fortunately by December, something like that, with an actual proof of concept of this now. Fortunately, yeah, I don't think it's gonna be that hard from our side to do it. In order to do this, we really want some support from people who are interested. So it's really not important in which way you consider it, but if you know of a use case of such a distributed system for multi-agent systems, it's really close to IoT level. So if you also have things regarding that, talk to us. We really want to validate this idea in as many sectors as we can. It doesn't mean like a full-on partnership. Just tell us if we're doing something right or where are we doing something wrong. This is really important for us. Then clients, if you actually know people who are investing for like 5 to 10 years from now who are willing to start working on this technology now, again, we're an enterprise solutions company. We want to know. We want to really find the clients for this. But now, which is most important, is we really want academic support. As we're writing a paper, I've wrote master papers. That's not the same as this level of really doing it proper with a good review and everything. So whoever has the support for this, please talk to us. You'll find us here. I'm head of R&D. Please, anything tech-related, coding, deployment, servers, IoT, great. Haischel is the founder and the CTO. So again, anything like programming language-wise, protocol level, great to talk to him. Alexander also is responsible for Kryha. So everything related to enterprise solutions, just talk to him. Anything related to blockchain, great as well. Thank you so much.